Hello dear students, welcome to the YouTube channel. In this video I am going to discuss about the different observations made by different scientists on photoelectric effect. So this is the second video that I am making on dual nature of radiation matter chapter. These concepts are really important for board examination point of view. Okay, so without delay let us start the video. Okay, now here I have written three observations. So Hertz observation, second one is Hallwach's observation, and third one is Lenard's observation. So Hertz is the one. Henrik Hertz is the one who discovered the photoelectric effect for the first time. This is very important for 1 mark. Okay, so we'll discuss about that in detail now. Okay, so next Hallwach, then Lenard. So they have used their own different methodologies and instruments to study photoelectric effect. You already know what is photoelectric effect, right? In the first video I have already explained, that is the process of emission of electrons from the surface of a metal by using light radiations or photons. Okay, light radiation or photons is called photoelectric effect. Okay, and I have also explained what is electron emission, types of electron emission, and what is work function, what is threshold frequency, what is threshold wavelength, what is stopping potential and all. Okay, so just do watch them, you will get the clear idea about that what is that electron emission. Then you can watch this video. Okay, so now let us start the video without delay. So first what I will do, I will explain, I will just read out what is the content which is there in this particular observation, then I will explain. Okay, so first one let us take, that is Hertz observation. What is there in Hertz observation? Okay. The phenomenon of photoelectric emission was discovered in 1887 by Henrik Hertz. In his experimental investigation on the production of electromagnetic waves by means of a spark discharge, Hertz observed that his high voltage sparks across the detector loop were enhanced or increased when the emitter plate was illuminated by UV radiation or light from an arc lamp. When light falls on the metal surface, some electrons near the surface absorb enough energy from the incident radiation to overcome the attraction of the positive ions in the material of the surface. After gaining sufficient energy from the incident light, the electrons escape from the surface of the metal into the surrounding space. So this is the theory behind this. Okay, now let me explain what exactly is this. Okay, so you remember Henrik Hertz. So he has taken one emitter plate. Emitter plate antandre adrinda electrons emit agta ide. So this is the material from which electrons are getting emitted. So he takes UV radiations, UV light or radiation. Yake UV radiation ತಗೊಳ್ತಾರೆ ಕಂಪೇರ್ ಟು ವೈಟ್ ಲೈಟ್. ಈಗ ನಾನು ಒಂದು ಟ್ಯೂಬ್ಲೈಟ್ ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ ಅಥವಾ ಬೇರೆ ಯಾವ್ದು ಇನ್ಕ್ಯಾಂಡಿಸೆಂಟ್ ಬಲ್ಬ್ ತಗೊಬಹುದು, ಅದರಿಂದ ಹೊರಗಡೆ ಬರುವಂತ ರೇಡಿಯೇಷನ್ಸ್ ಅಷ್ಟೊಂದು ಎನರ್ಜಿ ಇರೋದಿಲ್ಲ ಕಂಪೇರ್ ಟು ಯುವಿ ರೇಡಿಯೇಷನ್ಸ್. ಯುವಿ ರೇಡಿಯೇಷನ್ ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ದಟ್ಸ್ ವೈ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದಟ್. ನೌ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಆನ್ ದಿ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ ಎಮಿಟರ್ ಪ್ಲೇಟ್, ಮೆಟಲ್ ಪ್ಲೇಟ್, ಇದರಲ್ಲಿ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ಲೈಟ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಎನರ್ಜಿ ಅಂಡ್ ಕಮ್ಸ್ ಔಟ್. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಚೆ ಬರ್ತಾ ಇದೆಯಾ ಇಲ್ವಾ ಹೇಗೆ ನೋಡುವಂಥದ್ದು? ಮಾಮೂಲಿಯಾಗಿ ಬೈ using our naked eyes we can't see the electrons which are coming out because the size of the electrons is very small. Istirutte, see, if I write the mass of the electron, it is somewhere around 9.1 into 10 to the power minus 31 kg. ಎಷ್ಟು ಕಮ್ಮಿ ಇದೆ ನೋಡ್ರಿ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಷ್ಟು ಚಿಕ್ಕದಾಗಿರುತ್ತೆ. ಯು ಕಾಂಟ್ ಇವನ್ ಸೆನ್ಸ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಕಮಿಂಗ್ ಔಟ್. ಸೊ ಹೇಗೆ ಚೆಕ್ ಮಾಡುವಂಥದ್ದು? ಸೊ ಹಿ ಹ್ಯಾಸ್ ಪ್ಲೇಸ್ಡ್ ಒನ್ ಡಿಟೆಕ್ಟರ್ ಹಿಯರ್. ಇಲ್ಲೊಂದು ಡಿಟೆಕ್ಟರ್ ಇರ್ತಾನೆ, ಆಯ್ತಾ? ಸೊ ಈ ಡಿಟೆಕ್ಟರ್ ಇದ್ದಾಗ ವೆನ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಹಿಟ್ಸ್ ದಿಸ್ ಡಿಟೆಕ್ಟರ್, ದೇ ಹ್ಯಾವ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಸಮ್ ಸ್ಪಾರ್ಕ್ಸ್ ಅನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಸೊ ಫ್ರಮ್ ದಿಸ್ ಹಿ ಹ್ಯಾಸ್ ಕನ್ಕ್ಲೂಡೆಡ್ ದಟ್ yes, when sufficient amount of energy incident on the metal, UV radiation incident on the metal, the electrons present in the metal surface or on the metal surface observe that energy and comes out of it. So when they hit the detector plate, so they have produced these sparks. ಆ ಸ್ಪಾರ್ಕ್ಸ್ ಅನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತು. ಇನ್ನೂ ಜಾಸ್ತಿ ರೇಡಿಯೇಷನ್ಸ್ ಬಿಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆದಾಗ ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ವಾಟ್ ಇಸ್ ದಿಸ್, the sparks produced on the detector also increases or enhances. Okay, so this is the observation made by Hertz. So this could be asked for 2 marks in the board examination. Okay, now let us move on to learning the next observation, that is, what is that? Hallwach's observation. Okay, dear students, next we have the Hallwach's observations on photoelectric effect. Let me read it out. So the content is on the screen. Hallwach's in 1888, after the discovery of photoelectric effect by Hertz, okay, undertook the study further and connected a negatively charged zinc plate to an electroscope. Underline that, electroscope. See, electroscope is the device used to measure, what is that? Charge on a body. So this was asked in 2020, I think, in the board examination. So what is the instrument used to measure charge on a body? It is electroscope, or specifically it is gold leaf electroscope. Very important point. Okay, so he has observed that the zinc plate lost its charge, what is that, when it was illuminated by ultraviolet light. The uncharged zinc plate became positively charged when it was irradiated by UV light or ultraviolet light. So next, third point, positive charge on a positively charged zinc plate. Positive charge on a positively charged zinc plate was found to be further enhanced or increased when it was illuminated by ultraviolet light. So these are the observations done by Hallwach. Let me explain it in detail here. So he has taken first one negatively charged zinc plate and it has connected to an electroscope. Okay, this is the electroscope. So this is the instrument used to measure charge on a body. Very important point. So he observed that when UV radiations, UV light falls on the metal surface or zinc plate, the electrons present on the surface so absorb that energy and comes out. So when electron comes out, here it creates vacant place, that is called positive influence, positive charge. So this electron also comes out, again it becomes positive here. So this electron has also come out. So because one more photon is falling on it, one more photon is falling on it. So the, what is this? The body has lost its negativity. The body has lost its negativity. So then he has again conducted the same experiment for uncharged body. So here the number of protons and number of electrons are same, so it is called neutral body. So when light radiation, idr mele yavaga light bidutto, so UV radiations bidaga the electrons which are already bound with the electron comes out, then it will become positively charged. Again one more electron will come out with the absorption of energy. Okay, one more electron will come out, so it will get positively charged. There already free electrons ಎಲ್ಲ ಬಂದ್ಬಿಡುತ್ತೆ, ಇಲ್ಲಿ free electrons ಇತ್ತು, ಆಚೆ ಬಂತು. So here there is no free electron, but still free electrons will come out because of the incident radiation. Then he has observed the same experiment for the third plate which is already positively charged. ಇದು positive charge already ಇದೆ. So ಇದ್ರ ಮೇಲೆ ಏನಾದರೂ ಲೈಟ್ ಬಿದ್ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಚೆ ಬರುತ್ತಾ? Yes, we'll see. So when it's already 2 electrons have come out, so 2e is the charge here. So ಇದ್ರ ಮೇಲೆ ಬಿದ್ದಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಪ್ರೋಟಾನ್ ಜೊತೆ ಇರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಸಹ ಆಚೆ ಬರುತ್ತೆ. Again it creates, what is that, ಇಲ್ಲಿರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಆಚೆ ಬರುತ್ತೆ. Again it will become more positive. Firstly it was what is that, negatively charged plate, it will become uncharged. When this is uncharged body, it will become positively charged. If you take positive charged body, it will become much more positive. ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಕನ್ಸಿಸ್ಟೆಂಟ್ ಆಗಿ ಆಚೆ ಬರ್ತಾ ಇರುತ್ತೆ when light falls on the plate. This is the second observation made by Hallwach. Okay, so thirdly we have Lenard's observation, but he has used some kind of different instrumental setup. So I'll just draw it and explain the setup, and later we'll discuss about laws of photoelectric effect and all. Okay, let us start. Okay, thirdly we have the Lenard's observation on photoelectric effect, dear students. ಸೊ ಇಲ್ಲಿ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಅನ್ನು ಬರ್ತಿದ್ದೀನಿ ನಾನು, ಇದ್ರ ಬಗ್ಗೆ ದಿ ಕಂಪ್ಲೀಟ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಂಡ್ ಹೌ ಡಸ್ ಇಟ್ ವರ್ಕ್, ಹೌ ವೈ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಬ್ಯಾಟರಿ ಅಂಡ್ ಕಮ್ಯುಟೇಟರ್ ಅಂಡ್ ಆಲ್ ವಿಲ್ ಬಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ. ಓಕೆ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಸೊ ಇನ್ಸ್ಟ್ರೂಮೆಂಟಲ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಸಪರೇಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಡೀಟೇಲ್ ಆಗಿ. ಆಸ್ ಆಫ್ ನೌ ಐ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ವಾಟ್ Lenard has observed. Let me read it out. Lenard observed that when ultraviolet radiations were allowed to fall on the emitter plate of an evacuated glass tube enclosing two electrodes, metal plates. Okay, current flows in the circuit. As soon as the ultraviolet radiation were stopped, the current flow also stopped. These observations indicate that when UV radiations fall on the emitter plate, electrons are ejected from it, which are attracted towards the positive collector plate. Thus, light falling on the surface of the emitter causes the current in the external circuit. So now, if I explain what he has given in theory is, so here he has used one vacuum chamber that I have written here, okay, and connected to a battery commutator microammeter in series with the two plates. This is emitter plate which emits the electrons. Illi electrons irutte, so ee plate mele electrons emit agutte. So photoelectric effect ella agutte illi agutte. Photoelectric effect occurs here. So illi ಒಂದು window ಇದೆ ನೋಡಿ, quartz window. So when ultraviolet radiations falls on the ultraviolet radiations, UV radiations falls on the emitter plate, the electrons present on the emitter plate get emitted. The electrons emit ಆಯ್ತು. But how to get to know that electrons have got emitted? Electrons ಆಚೆ ಬಂದಿದೆ ಅಂತ ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ? So that's why he has utilized this anode plate, which has connected to microammeter, which measures the small current. ಆಯ್ತಾ? So ಯಾವಾಗ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೋಗಿ ಈ ಆನೋಡ್ ಅನ್ನ ಹಿಟ್ ಮಾಡುತ್ತೋ, when this electron hits this anode plate, when this electrons hits this anode plate, so there will be current generated in the circuit, external circuit. That small current is measured in this microammeter. ಯಾಕೆ ಮೈಕ್ರೋನೇ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ ಅಂತಂದ್ರೆ, why can't we use just what is that, milliammeter or just ammeter? Okay, so since the current generated is very small, that's why we have used what is that, microammeter here. So if whenever he stops this UV radiations to fall in it, electrons what is that, UV radiation stop ಮಾಡಿದ್ರೆ, ಲೈಟ್ ಅನ್ನು ಸ್ಟಾಪ್ ಮಾಡಿದ್ರೆ ಆದ್ಮೇಲೆ ಬೆಳಿಲ್ಲ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗೋದಿಲ್ಲ. when UV radiations won't fall on the emitter plate, no electrons get emitted, no current will be measured here. ಇಲ್ಲಿ current measure ಆಗೋದಿಲ್ಲ, ಆಯ್ತಾ? ಮೈಕ್ರೋಮೀಟರ್ ನೋಡಿರ್ತೀರಾ ನೀವು, otherwise you will see that in what is that, physics lab. Okay, so you can measure the current flowing through the circuit. So but when the light falls on the cathode plate, emitter plate, electrons get emitted. So here is the anode plate, produces the current measured here, and mugitu. So from that he has concluded that yes, when UV radiation falls on the emitter plate, the electrons are getting emitted. That is called photoelectric effect. How that he has observed, that concluded that electrons getting emitted by using this microammeter, because it is measuring some current. Okay na? So this is all about this video, dear students. We'll meet you in the next video. Till then, take care. Bye bye.